Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Munira Osman. I'm from Institute for Environment and Development, short form as Lestari. In Bahasa Melayu, we call as Institute Alam Sekitar dan Pembangunan, Universiti Kebangsaan Malaysia. As a research institute, I am a research fellow doing a research on air pollution, indoor air pollution and management. I am also have interest in life cycle assessment. My PhD is on measurement of carbon emission and also indoor air pollution. While for my master, I'm doing biomass burning impact, where I measured the emission from peat soil combustion, while my degree is on environmental science. Okay, for today lecture, I would like to discuss with you a topic on air sampling measurement and analysis. Okay, for today lecture, the content will be on the introduction of air pollutant, and then is the measurement of criteria air pollutants. The third one will be the instrumentation and method for analysis of gases and particulate matter, PM, short form as PM. And the last one will be PM 2.5 sampling and monitoring, particularly in Malaysia. Okay, actually, this is a video where I made this video for a contest in year 2019, but I would like to share with you this video on air pollution in Southeast Asia. I also uploaded this video in YouTube, so you can look at the link and look at and watch this video. Okay, as an introduction, air pollution in Southeast Asia mainly contributed from several factors, such as natural and also anthropogenic sources. We also have biomass burning, volcanic eruption, sea spray, which this aspect is actually an example of natural sources. We also have motor vehicles, industrial activity, power plant emission, which example for anthropogenic sources. We also have sort of an episode, air pollution episode, we call as haze episode, where haze episode is actually almost a yearly event in Malaysia and also few country in Southeast Asia, which related to dry season and also biomass burning event. Okay, for this slide, I put here a map, a world map, which have lots of red dots here. We have lots of red dots in Southeast Asia, in Asia, several area in Africa, and also in the United States. So it's actually a hotspot which measured or captured by the satellite to show the distribution of hotspots around the world. So we can see that Southeast Asia have uh, densely with biomass burning and also a hotspot, which actually contribute to air pollution. Um, for this lecture, I would like to also explain with all of you about the different type of biomass burning. Okay, basically, biomass burning can be from the soil and also from the agriculture. But for Malaysia and Indonesia, it's actually the biomass burning. It's actually from the pit soil combustion, where in Indonesia and also Malaysia we have a very large area of peatland, pit soil. Pit soil and pit soil is actually a very black soil. It is very suitable for agriculture, and actually the characteristic of peatland is it is have high water level, high water, and it's always with water around the area. Moreover, pit soil or peatland have black color. It is very what we call as subur in Bahasa Melayu, and usually uh, the land is usually been cleared to plant several plantation of several type of agriculture, such as palm oil plantation, and also other types of plantation, um, usually for paddy, for pineapple, and so on. In Sumatra and Kalimantan, usually Indonesia is actually have a very large area of peatland, which is one of the largest area in the world. Okay, so the area of peatland um, been uh, been used for it's been cleared by human activity, anthropogenic activity, to convert this natural area to a plantation area. So peatland is actually very easy to get burned, easy to have a fire around this area. Okay, as you can see in this figure, I put a schematic design of a pit combustion where we can see on the surface of the Earth's surface, we can the area can get burned with lots of smoke, and then it will it will have ignition of fire in the subsurface for 1 day, for 1 week, 1 month, and also a year down down under the subsurface. So the pit soil actually it can retain the heat under the subsurface, and a fire can be occurred in other area due to um, the heat inside or under the subsurface. So pit conversion is actually can be naturally, or maybe can be done, or it's actually can naturally uh, get on fire, and also it's burned by human for land clearing and so on. So land clearing, it's usually the main cause of pit combustion, especially in Kalimantan, in Sumatra, and also several area in Peninsular Malaysia, such as in Banting, Kuala Langat, and that have uh, an area of pit soil, pit area in Banting, in Kuala Langat. Actually, I have experience during my master studies. My master is on biomass burning and pit soil combustion. So I went to Kuala Langat, where Kuala Langat is my study area for my master studies, where I went Kuala Langat with forestry department. So they brought me to the area which usually get burned. So I just go there, and then I found out that they have a channel around the area, channels where the pit combustion it's just in the area with the channels. So the water from the peatland or pit area will be drained out. So they drain out the water, the area get dry, and then they plant for agriculture, such as oil palm or palm oil around that area. So I went to the Kuala Langat Utara, Kuala Langat Selatan. There are two type of forest area there, Kuala Langat Utara and Kuala Langat Selatan. So basically the issues is just like that. The people will go to the area, and then land clearing, drain out the water from the peatland, and do some plantation there. So the soil get dry and get burned easily, especially during dry season, during southwest monsoon, especially in September. So the fire is very hard to extinguish, very hard to reduce the fire, and usually bomber, the fire department, will come and try to extinguish the fire, but actually it's very hard. When you look at this schematic design, you can see that the fire is down there in subsurface, so it's very hard to extinguish this type of fires in peatland. The peatland is usually happen in Malaysia and Indonesia, while for Indochina, such as Thailand, Myanmar, Laos, at the upper area of Southeast Asia, they also have biomass burning, but they are usually related to agriculture waste, where the agriculture waste being burned for them to start a new agriculture phase. So they burn the rice straw, they burn the waste from the agriculture, and they have a large area of agriculture. The area is very large, and it is very fertile land for agriculture. So in Indonesia, in Indochina, the upper area of Thailand, Myanmar, and so on. So they have a biomass burning, but related to agriculture waste. Okay, we will start our lecture today. We'll go to the next piece or next slide on the measurement of air pollutants. Measurement of air quality or air pollutant generally fall into three main classes. The first one is measurement of emissions. The second one, meteorological measurement. And the third one is ambient air quality. The measurement of emission is called a source sampling, when a particular emission source is measured, and generally based on the spot test, on the spot test. While for meteorological measurement is actually measured meteorological factor that show how the pollutants are transferred from the source to other places. While for ambient air quality measurement, it's measured the quality of the air in a very specific or particular place, and almost all the evidence of health effects is based on this measurement. Okay, so for health effect of air pollutant, we usually using the data from ambient air quality. Okay, while meteorological measurement, it's we want to know the source or how the pollutant has been transferred. While measurement of emission is on the spot, you need to measure it on the spot or in the specific site, such as a traffic emission. So this three is the type of measurement of air quality. Moreover, we also have other type of air measurement of air pollutants, uh, where it is also industrial hygiene sampling, where it is specifically usually in indoor, to see the air quality inside a factory or a workplace, where we will measure the air pollutants, but in a confined space, in indoor. And the other measurement is residential indoor sampling, which is specifically for residential and looking on indoor air. So both industrial hygiene sampling and industrial indoor sampling, both is in indoor environment, and it evaluate the pollutants inside workplace, inside houses, schools, office, and other type of indoor indoor environment. Okay, before we want to start for the measurement, to start measurement of air pollutant in a specific site, we need to have several things to gather in order to have a good measurement, or to have a good to have accurate measurement. First requirement will be we need to know the purpose of the monitoring. The second one is number and type of instrument required. The third one will be the duration of measurements. The fourth one, best available general guide. And the last one, the fifth one, it should be easily accessible. So when we want to have a measurement in certain area, first we need to know what is our objective, what is the purpose, what is the aim of the measurement. So we need to have a very detailed objective for the monitoring. We also need to determine the number of instrument needed and the number of area. So we cannot just doing some measurement without have a detailed planning. Okay, we need to have a detailed planning. How long is the measurement? What is the type of the environment that we want to measure? What is type of pollutant that we want to measure? And what is instrument that is required for the measurement? So that's a few things that we need to very clarify and very in details on the measurement. The duration will be maybe 24 hours, maybe 8 hours, maybe a a measurement campaign that 1 month, 2 month, or maybe according to the season, southwest monsoon, or northeast monsoon, or maybe a measurement for a 1 year. So we need to have a um, very detailed planning for the measurement. We also need to check for the best guide. Okay, best guide, best SOP, best requirement, such as for indoor measurement. um, you need to know what is the requirement. You need to know what is the guideline, or what is the recommendation, or how is the sampling being done, because for indoor and outdoor is different. Indoor measurement is different from outdoor measurement. So we need to actually very detail, and also know what is the best guideline for the measurement, maybe in indoor and outdoor. And the measurement site should be easily accessible. I just put it should be because um, sometimes we need to measure it. The area will be hard to be assessed, hard to be assessed. So um, uh, make sure that the sampling area is as easily to be accessed, or such as it can be no harm for us to go to the site. And certain area need permission. In certain site we need permission, such as in school we need the permission from the headmaster, headmistress. And also for measurement in school, the ministry, we need to apply the permission from the ministry. So it is not easy. We need to apply for permission. We need to have a good planning for the measurement, and we need to have a good instrument for the measurement. And one of the important thing is that it's easily to be assessed. Okay, choice of monitoring equipment. I just put here few uh, few types of uh, alternative, which we need to think about it before we going for measurement or going for monitoring. Uh, the most important thing is we have the equipment, but we need to think about the several aspect as well, such as cost. We need to think about the number of data points required. We need to check the data, which data being used, the purpose of the data being used, the time interval, the device's power requirement, type of air pollutants, and the environment in which the monitoring equipment is being placed. Okay, for cost, we need to make sure that it's not very costly because actually air pollution equipment or air pollution measuring instrument, it's very costly. It's more than 20,000. Usually uh, we need to be we need to have a good planning to make sure that the cost it's within our budget when we want to buy equipment or instrument. But usually like myself, I have a several other instrument where the instrument is actually bought from our research grant. I also in a group with Professor Muhammad Tariq Latif. Professor Muhammad Tariq Latif is one of the air pollution experts in Malaysia. So Professor Muhammad Tariq Latif have a few air pollution grants recently and before this. So he bought several instruments for measurement of air pollutant. So sometimes we need to rent. We need to have a rental of instrument. So before we go from measurement or for sampling, the most important thing is cost, because we need to think about the cost during the field work as well, during the measurement as well. Sometimes the area or the site is far away, right? Far. So we need to have a detailed cost for the transportation, for the logistic and so on. The second one, number of data points is also important, such as if we want to measure it for air pollution in indoor environment, there are some specific requirement by Department of Safety and Health where a certain area we need to have several points for measurement. But for outdoor or ambient air measurement, it's actually depends to the study because sometimes we need to measure the air pollutants in different background area, different surrounding or therefore different environment. So it is important to also look at the location as well. What is the setting on the specific site? So we can have some maybe comparison between urban area with rural area, coastal area with other type of area of environment. Okay, the purpose of which data is being used means that how we want to maybe provide or analyze the data. Is the data need to be daily data, or the data need to be hourly data, or you want to have a diurnal or daily trend of air pollutants? So you need to be careful and think about what analysis data that you want to perform. Time interval required between data points means that how long uh, the data between each data, is it 1 minute, one hour, or you want to compare it between days, weekdays or non-weekdays. So it's depends on your study design. Device power requirement. This is a very important aspect because certain instrument need electric power supply. Certain instrument just need battery. So you need to charge the instrument, then you can go for sampling. But certain instrument, you need to have a power electric, and then you can operate or switch on the instrument. So before go to sampling, we usually need to have a recce, or we need to check for the environment, to check for the power supply. Whether it is depend on your instrument as well, because for my research, sometimes I can use a battery operated instrument, but it need to be supported with electric or power supply as well. So I need to use electric as well. So the most important thing is to check for the electric or power supply. And then the type of air pollutants, we need to know what is the pollutants that we want to measure. Is it gases or particulate or a VOC, volatile organic compound, or so on. So you need to better identify and have a detailed plan for the measurement. Okay. Okay, for this slide, we'll discuss or explain to you about the air sampling technique. Most of air pollutant monitoring equipment perform the act of sampling analysis in one action, which is real-time measurement, while all instrument is actually intermittent sampling, time lag between when the samples was obtained and when the data was available. Okay, for the first one, is actually a new type of instrument. We can measure the air pollutant such as PM10, PM2.5 in real time. Okay, in real time. So you can have the concentration of air pollutant instantly. You can see at the instrument and you can find the concentration of air pollutant. While for the old equipment, it is intermittent sampling, which is you need to sample the pollutant, and then maybe you need to do some analysis. Then you will have the concentration of the pollutant. So both of these technique have their own uh, pro and cons actually. So it's depend on your measurement or your sampling objective. So both can be used for measurement, whether it's real-time measurement or intermittent sampling. It's depend on your type of studies. Okay, for this slide, just want to touch on the analysis analysis of gases, where there's a few type of measurement. We include absorption into specific solution, where we can in this slide you can see that there's a pump here and also a vials. So in the vials is a specific solution, and the pump will absorb or pump for pollutant, and it will absorb in the solution. And then we also have colorimetric methods, which is comparing the color or comparing the solution consistency, and then it will calibrate with a graph of a chart. And for determination of gases, it's actually intermittent sampling, where when you want to use the instrument, you need to sampling. You go sampling, sample the gas, and then bring to the lab and doing some measurement or analysis. Usually, it's usually for this type of analysis, it's just a simple instrument. Like I put in here a figure. It is actually air sampling pump. It is portable and it's have battery. So when you want to have a measurement, then you will go to the field, you switch on the pump, and then the pump will when it's operated or when it's on, the air will be drawn into the solution, and then from the solution you will go to analyze it using colorimetric methods, or also to compare it with a graph. Usually the manufacturer of the instrument or the solution will provide you a graph where you can have the concentration of air pollution or air pollutant. So when after you have sampling, after you go back after you have performed the sampling, you will go back to the lab, and then you will compare it with the graph. Okay, for this slide, is on the real-time measurement. The previous slide is on the intermittent. measurement. So for real-time measurement, there's a few measurement or mechanism to analyze the concentration of gases or specific gases, such as sulfur dioxide. The instrument use UV fluorescence, known as electrochemical method. For NOx, it is using chemiluminescence mechanism. For ozone, also chemiluminescence and UV method. While for CO, carbon monoxide, usually for real-time measurement, it is using non-dispersive infrared mechanism inside the instrument. Okay. Moreover, usually for gases, the unit will be ppm or ppb, and widely used in as air pollution scientific committee, and the unit can be in microgram per liter or micromole per mole. It depends on the instrument, but usually for gases it's usually ppm or ppb. Okay, we come to the measurement of PM, particulate matter. Before this, we discussed about gases, and right now is the measurement of particulate matter. Mechanism for particulate matter measurement, usually using beta attenuation method. It is a real-time measurement. Then we also have tapered elemental oscillating microbalance. It's also real-time measurement. The third one will be optical light scattering under real-time measurement. And the last one, gravimetric method. This is intermittent measurement. So for measurement of PM, we have three measurement for real-time. And I stated here one method for intermittent measurement, which is gravimetric method. Okay, so what is different between each of the mechanism? Okay, for beta attenuation method, it is actually based on the beta attenuation absorption meter. So this mechanism, it's inside the instrument, so we cannot see this. It is inside the instrument. Usually, the instrument that using this mechanism, it's actually very big, very big. So this is the mechanism inside the instrument. Okay, this is the schematic design of beta attenuation method. As you can see here, it have a very detailed and very special, which in our Jabatan Sekitar Department of Environment measurement site, we have this instrument where this is inside a cabin, actually in our monitoring station under Jabatan Alam Sekitar or Department of Environment. The sensor, or the top of the sensor, if you can see here, this one will be outside of the cabin, and this one will be inside the cabin. So the outer part here is actually the inlet. So the air will be drowned into this. It will drop inside and be analyzed in the cabin. So the data or the concentration of PM will be displayed here. Okay, advantages of the beta attenuation method include the provision of data at an hourly time. It is hourly, and also can be few seconds duration of time. And it is low labor, which is low maintenance, and material cost associated is ongoing operation, because this actually being used by our the Department of Environment to measure the particulate matter in several areas in Malaysia. A number of different beta attenuation analyzers have gained US EPA equivalency status for measuring PM10. Yes, US EPA is a standard that US EPA given the standard to instrument where they are recommend beta attenuation as measurement mechanism for PM10. Okay, this is the second type of particulate matter mechanism measured using tapered elemental oscillating microbalance. Basically, it's actually it a microbalance. It is a balance that is inside the instrument. So it's measured the weight of the particulate. So inside the instrument, it measured the weight of particles, and then it uh, calculated the concentration of particulate matter. Okay, this is the a picture of Theom. It is very big actually. It is maybe my heights. So it is big, and usually it's been used for measurement of particulate matter PM 2.5 in several station, also in the cabin. So the air will be drowned inside the instrument, and then the concentration of particulate matter will be displayed in here. The element contains a filter where the instrument have a filter inside which particles are deposited. So in the filter, the particle will be deposited, and then it will measure the weight of the particle, and the analyzer will calculate the concentration based on the flow rate, uh, and the cut point is achieved at 3 liters per minute of the air is passed across the filter. The Theom sensing system is heated to drive off water, which where actually particles it's very sensitive to water. So this instrument using a system to heat the drive of water and minimize the effect of thermal expansion. Okay, the next one, optical sampling. Okay, optical samplers which use principle of light scattering is to use for particles using the particle mass, estimate the particle mass, usually used by GRIM, Data, RAM, and GT1020. It is actually a model for instrument. In addition, a problem can arise as a result of light scattering. Okay, certain instruments have such as a problem for 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 light scattering, and one of the uh, aspect will be moisture. As I mentioned before, moisture is important, which can affect the concentration or the measurement of particles. So it is very important to make sure that the moisture is low, and uh, uh, make sure that the particle can be sensed through light scattering, because it will have a LED inside the instrument to measure the particle. So it's important to make sure that it's low of moisture, and to make sure that the sensor or the instrument is calibrated. I have also using a sensors, which is an optical sensors here. It is a small, like a very small type. It's like here with me. So if you can see here is a optical sensor using principle of light scattering. So you will have a real-time measurement of PM10, PM2.5, and PM1. Okay, this is schematic design of light scattering principle, where, as I mentioned before, is using lights to reflect the particle in the sensor, and then it will separate the scattered the measured the scattered light, and then the concentration of diameter of the particle will be read through the inlet inside the sensors, and then give the concentration of the particulate matter. Okay, this is a summary of air sampling measurement. As I mentioned before, we have real-time measurement and also intermittent sampling. For real-time measurement is aerosol particles like PM, light scattering, and so on. Reactive gases, as I mentioned in the early of the class, is a reactive gas which we can use air sampling pump. And while local meteorological data, we also usually the parameter that's been measured is temperature, relative humidity, rainfall, wind vector, and so on. For intermittent sampling, I put here two types of measurement: high and low volume sampler, and also grab sampling. Grab sampling usually being used for VOCs. For grab sampling, it's you go to the area for measurement, and then you bring the sample to the lab and then analyze using uh, instruments such as gas chromatography and so on. While for measurement using high or low volume sampler, it's have a filter paper inside the instrument, and then the filter paper will be weighed before and after sampling, and the filter paper will bring to the lab for analysis. It's depend on what you want to measure, maybe ion or water soluble composition, or you want to measure trace metal composition, or you want to measure the organic composition. So it depends. Each of the elements or composition that you want to measure, it will have different type of instrument to analyze the filter paper or to analyze the result of your targeted compound. Okay, I just want to show you online information on air pollution in his episode. We have an online database such as EOSDIS by NASA. So you can see the fires or hotspot in certain area. You can just zoom in and give the date or month of your targeted time. So it will display the hotspots in certain areas. And this one is from windy.com. So you can choose few parameters such as PM 2.5, PM10, ozone, and O2. You can just select which parameter that you want and which date, that you want to have view the concentration of a pollutant. Then it will display the trajectory of the pollutant. So it is very interesting. So you can just go to windy.com and try for yourself. It's very interesting, and you can see the graphic on the concentration movement. Okay, and this one is a hotspot distribution map provided by ASMC. Is a website from Singapore. So you can just go to this website and just pick or select a date that you want to view, and then it will provide you the location and the selected parameter that you want to view, and the dispersion of air pollutants in graphical figure. Okay, for the next slide, we'll talk about trajectory analysis. The first one will be high speed, where high speed is a backward and forward trajectory models. You can just select whether you want to have a backward or forward trajectory. This is the output from the high speed, where you can see there's a line here, the black line. So the black line is show the movement of air masses, or the movement of wind from one location to other location. So if it backward, you can see what is the movement of the wind to the location that you want to study. or if the forward analysis, you will see what is the movement of wind or air masses from your location to other location. So you need to set up the longitude and latitude of your location, and then you need to set up the meteorological data as well, and then you will analyze. It will display your result in terms of map. Okay, so it's very interesting. So you can see the movement of air masses or the trajectory of wind. While this one is the a trajectory model as well, but it is under NAME model, numerical atmospheric dispersion modeling environment, NAME. It is actually a UK type of software where it coupled with fire hotspot data. So you can see where is the movement of wind from, such as in this figure, the movement of wind and emission. It is coupled with emission data as well. So you can see the trajectory of the wind. Okay, next will be specifically on the PM 2.5 measurement. Okay, particulate matter, PM, is a generic term used for a type of air pollutant consisting of complex and varying mixtures of particles. PM can be varied in size, in composition, and produced by a wide variety of natural and anthropogenic activity. Most of ambient air pollutants or most ambient air quality measurement include monitoring of PM 2.5, PM10, PM1 nanoparticle, and so on. But usually right now, it is a mainstream to measure the PM 2.5. So PM 2.5 is one of the important size of particulate matter that usually being measured to relate it with human health. Okay, this is a figure to show the size distribution of PM. So as you can see here, each PM size is have a different mode of accumulation or mode of concentration, where PM10 and TSP. What is TSP? TSP actually total suspended particulates. So it is coarse actually, coarse particles, and PM 2.5 usually in accumulation mode, while PM 0.1 or nanoparticle is in nucleation or ultrafine mode. Alright, this is a figure that shows a relative comparison for PM 2.5 and PM10. As you can see here, PM 2.5 is much smaller than PM10, and PM10 is about, I don't know, maybe five times smaller than the diameter of our hair, our hair. So it is very hard to see in the ambient air. We cannot see PM10 or PM 2.5 with our eyes. So it's very small, and it's very tiny and suspended in our air. For PM 2.5 measurement, usually being performed using high volume sampler (HVS). It has a filter paper inside the instrument. So when you want to perform the sampling, you need to open this top of the instrument, and then you need to put the filter paper inside it and use for about 24-hour measurement in the ambient air. And usually it been located in high level, such as in rooftop for ambient air measurement. And this one is a low volume sampler, short form or usually being called LVS, low volume sampler. It is quite small, but the mechanism or the function is a different. It is a same. LVS is same function as high volume sampler. but the size is different. Okay, the size is different. And for LVS, it usually use for measurement for 8 hours or 24 hours. But for LVS, it's normally 24 hours. Okay, so it have a small type of filter inside it where we need to replace the filter every time we want to do measurement. Okay, and the filter need to be weighted and dry in the desiccator before and after sampling. Okay, basically for LVS and HVS, it use gravimetric sampling method, where gravimetric is actually uh, a type of measurement using weight of the filter paper. So for both HVS and LVS, is using the filter paper. So for gravimetric sampling, you need to weigh the filter paper before and after, and then you need to calculate the concentration based on the flow rate and also how long the measurement been performed. Okay, this is the figure for desiccator and also 5-digit analytical balance. Desiccator being used for to dry the filter paper before and after sampling, or to dry the filter paper for 24 hours, at least 24 hours before sampling and after sampling. Okay, so basically it's good to have to try the filter paper 48 hours 48 hours, but 24 hours is good enough. But uh, the most important thing is to make sure that the filter paper is dry before and after sampling. While for analytical balance, it's been used to weigh the filter paper. This is very sensitive balance. It is 5-digit, and you need to carefully put the filter paper inside the balance and weigh for the filter of the weight of the filter. So it's actually good to have 5-digit balance, while to make sure that the calculation of particulate matter is accurate. So uh, it's highly recommended to use 5-digit analytical balance. Okay, I just put here a figure of filter paper after sampling. You can see that it's a very dark black color on the top of the filter. So this is the dust or particle that been absorbed on the top of filter paper. So after you have sampling, after you have performed sampling, you will bring back this filter paper to the lab, weigh the filter paper using 5-digit analytical balance. Then you will have the weight of the particle, and then you need to calculate the concentration of particle, whether it's PM10 or PM2.5. Okay, next, after sampling and you have bring the filter paper back to the lab, you need to perform the analysis, which is include the composition of particulate matter. For anion and cation, water soluble, you need to analyze using ion chromatography. For organic substance or organic compound, you need to analyze using gas chromatography. While for metals, can be analyzed using atomic absorption spectrophotometer (AAS) or inductively coupled plasma mass spectrometry (ICP-MS). So AAS and ICP-MS been used to analyze the metals concentration in sample. So usually for AAS and ICP-MS, you will have several elements, very uh, uh, more than 30 types of element can be analyzed, especially by ICP-MS, to know the element concentration in the particulate matter. Okay, I just put here some photos of instrument used in our lab. There's a ion chromatography here on the left side. In the center is gas chromatography, where gas chromatography is being used for organic compound, to analyze the organic compound, while ICP-MS is being used for metals to determine the concentration of elemental metals. Okay, I just put some picture here on the digestion of filter paper. As I mentioned before, when you bring back your filter paper to the lab, you need to do some digestion. You cannot just analyze it with ICP-MS or ion chromatography. You cannot. You need to digest the sample in the lab, doing some dilution, put some acid for digestion, or put some diurnous water or so on. So it's depend on what analysis of compound that you want to measure. Every compound have different method. Every compound have different method. So you need to carefully have a standard method to be used to digest the filter in order to have accurate or to have a good analysis data for each compound. Okay, for organic compound, ions are water soluble and metals is actually inorganic compound. As I listed here, ions can be sulfate, nitrate, fluoride, ammonium, calcium, magnesium, potassium, sodium, and so on. So that's an element for ions. While for metals, it can be lead, zinc, cadmium, copper, iron, chromium, manganese, aluminium, and so on. So this is type of element for trace metal. So when you analyze the concentration of water soluble or ions and trace metal, you will analyze using the instrument, right? IC, ICP. So from the instrument, from IC and ICP, you will have the concentration of each of the ion and trace metals. There's also an organic biomarker called as levoglucosan. Levoglucosan is actually organic compound usually been determined for indicator for biomass burning. So if we want to determine the effect of biomass burning, we usually determine levoglucosan concentration. Levoglucosan concentration is actually we call as organic, and it need to be analyzed using gas chromatography. Okay, so this is a chemical structure of levoglucosan, and when the biomass burning occur, levoglucosan concentration will be higher. Okay. Okay, for the next slide, I will discuss a topic on source apportionment. Source apportionment is one of the aspect that's been applied or been used to know the source of pollutant or particulate matter. So it's include a receptor model where it's actually a type of statistical analysis, and there are a few type of receptor model such as multivariate model, PCA, principal component analysis, PMF, positive metric factorization, and so on. There's lots of analysis being used in order to determine the source of uh, pollutant or analysis of source apportionment of particulate matter. By using receptor models, basically I'm using PMF, positive metric factorization, and also PCA. PCA is principal component analysis. From this analysis, we can determine the source of composition, whether the PM 2.5 come from vehicle emission, or from the industrial emission, or from the wildfires, and so on. So from this analysis of PMF, CMB or PCA, CMB is uh, I'm not sure the cumulative mass balance, if I'm not mistaken. So all of these three analysis being used to calculate the source and source composition of uh, of particles of source, each source to the PM2.5. Moreover, we also have analysis of chemical mass closure. It's based on the calculation of several elements or source which have been determined using the analysis of composition. Just now I mentioned about the analysis using ion chromatography, um, uh, ICP-MS. So from the analysis for the concentration will be grouped into sea salt, dust, uh, uh, SiA, and then we also have trace metal, black carbon, and so on. So SiA is secondary inorganic aerosol. So it's actually we group the elements into this factor, and then we calculate the chemical mass balance. It's actually a very straightforward calculation, but need reference for the each element, such as potassium and so on. There's a what we call as per kali, or the value that need to be multiplied with the element concentration. So it's actually a calculation of each element that we group the element in one factor, and then we sum out the factor to have a whole concentration of PM2.5, for example. For source apportionment, using positive metric factorization, PMF, as I mentioned before, there's a well-known software introduced by US EPA. It's actually online or free online, so you can download it and analyze for our data and use the software to model the concentration of the element concentration of PM2.5 or PM10 and so on. Okay, this slide I will discuss about air quality monitoring in Malaysia. Basically, in Malaysia, under Department of Environment, we have measurement for parameters such as PM10, PM2.5, sulfur dioxide, nitrogen dioxide, ozone, and carbon monoxide. Okay, we also DOE or Jabatan Alam Sekitar also measured several other meteorological parameter, such more towards the meteorological data of temperature, wind direction, humidity. So just a bit basic meteorological parameter. And the measurement of air quality in Malaysia usually using the standard method by US EPA. So right now, under Department of Environment, we have 65 sampling station around Malaysia, and we have, if I'm not mistaken, 14 or 15 manual station which includes the measurement of HBS using the filter paper. The PM10 and PM2.5 here is actually a real-time measurement by Department of Environment. Department of Environment also have a instrument for manual measurement using HVS in 14 or 15 station only in Peninsular Malaysia. And the location is, if I'm not mistaken, like Pasir Gudang, Kuantan, only in selected cities in Peninsular Malaysia. Okay, this is a snapshot of APIM's website under Department of Environment. So you can Google it. Just type APIM DOE. So you can see a figure that shows air pollution index in selected area in selected station in Malaysia. So you can see that in each color, green and blue is a station, and it's indicate the quality of air pollution, air pollutant in selected area. If it's in green color, is a moderate API value, or if it blue, is a good air pollution index. So by using this website, you can see the status of air quality in Malaysia daily. Okay. All right. As I mentioned before, we have 65 continuous air quality station in Malaysia and 14 manual air quality station. If I'm not mistaken, right now it's 15 because there's a additional station for manual air quality monitoring. So right now it's 15 manual station, and for continuous air quality monitoring is 65 station. Okay. I think that's all from me. I hope that all the students can have a look at the slide, and if you have any question, just give some uh, question, or you can email me at this email address, and try to can have communication with me, so I can answer your question, or you can have some question and answer by email or so on. So that's all for me. Thank you very much.